In today's session, we shall look into the introduction to electric traction. We all of us have travelled in some type of the trains or the other. Now let's have a look at the model of the train. This is the model of the train. Right? Traction is the system of propulsion of trains on the tracks. Electric traction involves electric energy for this purpose. We have the electric traction are classified basically into two types. Now we shall look into the classification of electric traction. The first type is the systems which use electric energy at some stage or the other, such as diesel engine drive, battery drive and straight electric drive. This picture shows us the straight electric drive. There are the other systems which do not use the electric energy at any stage. They are the steam engine drive and internal combustion engine drive. This picture shows us the steam engine drive. Now we shall go into its history. The electric traction was first introduced in British Railways in 1890 with 600 volt DC system. In India, it was first introduced in 1925 between Bombay VT to Igatpur and Pune with the 1500 volt DC system. But the electrification in India on a large scale took place only after independence. Later on, AC system was found to be more advantageous and hence a single phase 50 Hz 25 kilowatt AC system was developed. The electric traction basically uses electric motors as they drive. The electric drive has got many advantages over the other forms of drives, especially the steam drive. Now we shall look into the various advantages of electric drive over steam drive. Right? The first advantage is its high starting torque. Electric motors have got very high starting torque which result in the high acceleration rates of 1.5 to 2.5 kilometer per hour per second. Instead, the steam engines have an acceleration rates of 0.6 to 0.8 kilometer per hour per second. This high starting torque results into the high schedule speeds, high traffic handling capacity. The traffic handling capacity of electric locomotive is over the double that of the steam locomotive. Because of the high schedule speeds and high starting torque, less terminal space is required by the locomotive. This is a very important factor in urban areas. The next advantage is its cleanliness. The electric locomotives have no smoke and hence they are best suited for underground and tube railways. Because of the absence of smoke and spark, there is not only a greater safety to the drive but damage to the buildings and the apparatus is not caused because of the corrosive fumes. The next advantage is it has greater traffic density and greater industrialization. Owing to cleaner, quicker and more comfortable passenger travel and it leads to greater traffic density. Also Because it provides a greater transport facilities, it leads to greater industrialization. The next advantage is it provides most important base load. The power requirement for the electric locomotive is of the order of 0.5 kilowatt per track kilometer. This is a sizable load which tries to improve the power development schemes. This also improves the load factor to 60 to 70%, and hence this electric locomotive provides good base load. The next advantage is it encourages rural electrification. The track electrification encourages rural electrification as no special transmission lines have to be set up for the purpose. The next advantage is it's the greater availability of rolling stock. Previously, when steam engines were used, all the wagons were used to carry the coal required for the steam locomotive. But now that electrical locomotives are used, these wagons are released for the transportation of various types of goods, thus providing the availability of rolling stock. The next advantage is its flexibility in operation. In urban areas, during the morning and in the evening, there will be a heavy inrush in traffic, but at the midday the traffic is light. It is possible for the electric locomotives to run shorter trains during this period. This flexibility is not there in steam engine or the other types of engines. The next advantage is its easy maintenance. The maintenance cost and also the maintenance time of the electric locomotive is much less compared to steam engine drives. It's about nearly 50% less compared to steam engine drives. The next advantage is its less starting time. The electric locomotives can start immediately with a moment's notice, but it takes nearly 2 hours for the steam locomotive to get heated up for propulsion. The other advantage is the saving in high grade coal. High grade coal is used in steam engines. The electric engines receive power either from hydroelectric stations or from pit head thermal stations which use only low grade coal. Thus, high grade coal is saved for metallurgical purposes. The next advantage is the saving in ancillary equipment and repair facilities. Because of the absence of coal pits, ash pits and water collecting pits, the workshops to be set up for the electric locomotive is much smaller compared to the steam locomotives. And hence, there is a high saving in ancillary equipment and repair facilities. The next advantage is the center of gravity is less. The center of gravity of electric locomotive is much less compared to steam locomotive. This enables to have the steep curves on the gradients. Right. The next and the most important advantage is its regenerative braking. The braking system used in electric locomotives is the regenerative braking. The regenerative braking has got many advantages. The advantages of regenerative braking are about 80% of energy spent during ascent is pumped back during descent. Goods traffic on gradients is more safe and speedy. Less maintenance of brake shoe, wheels, tires and rails on account of less wear and tear. The other advantage of the electric locomotive is the absence of unbalanced forces. Due to the absence of unbalanced forces because of the reciprocating masses, the coefficient of adhesion of the locomotive is high. It is nearly about 45%. It reduces the weight per HP ratio of the locomotive. It improves the riding qualities. It reduces the wear and tear of the track. The other advantage is its operational convenience. In electric locomotive, it is possible to place all the power units in 2 or more power cars, and the controlling of the power units can be made from a single place. Generally, the controlling is automatic and remote controlled. So, now we shall look into the different points of operational convenience. The controlling all the power units from one point. The electric locomotive can work under overload condition for short time. Electric locomotive can run under overload condition for short time by drawing unlimited power from the source. This is not possible in case of steam engine drive. In case of steam engine drive, if at all it is overloaded, there will be much strain put on its crew. But the strain put on the crew of the electric locomotive is much less. Because of the regenerative and rheostatic braking of electric locomotive, time schedules can be maintained on the down gradients. The last and very important advantage of electric locomotive is the increase in the line capacity. The line capacity is determined by the speed of the slowest moving vehicle on the system, that is the goods trains. Because the electric locomotives have got high coefficient of adhesion of 45%, and because the electric locomotive has got less weight compared to steam locomotive, high acceleration and retardation rates are possible, which results in the high speed of goods trains as well. High acceleration and braking rates result in high speeds of goods trains. So far, we have seen the different advantages of electric locomotive or the electric drive over the other forms of drive. Now, in fact, these drives have got some disadvantages also. Now, we shall look into the various disadvantages of electric drive. They are, firstly, there is a high capital outlay of overhead supply system. Hence, unless heavy traffic is to be handled, the electric locomotive becomes uneconomical. The next disadvantage is the interference with communication lines. The communication lines which run parallel with the power lines set up for the locomotive cause interference, what we call it as radio interference, and hence in order to avoid this, the communication lines must either to be removed from the track or special expensive cables are to be set up for the purpose. The next disadvantage is a negative booster has to be provided. If the negative booster is not provided, the return current through the ground causes corrosion to the underground pipework and the underground telephone and telegraph networks. The next disadvantage is that it is tied up to electrified routes. Only when we have electrified routes, these locomotives can run across, otherwise these locomotives cannot run. The last disadvantage is the dislocation of traffic due to power failure. Due to the power failure of few minutes, there will be a dislocation of traffic for few hours. This is a major drawback in electric drives. So far we have seen about the various advantages and disadvantages of the drives. Now we shall look into the systems of track electrification. There are 5 systems of track electrification. They are the direct current system or the DC system, single phase low frequency AC system, single phase high frequency AC system, 3 phase AC system and composite system. Before going into details of these systems, we will just have a look at the various equipment used in these systems. The first is the electric locomotive. This is the diagram of the electric locomotive. It has got the overhead equipment which receives power from the substations. This is a pantograph collector which acts as a link between the overhead equipment and the supply system on the locomotive. The current collection gear of the overhead equipment collects the current from the substations and sends it to the pantograph or the different overhead collectors. These current collector gear equipment must work under any conditions, any climatic conditions and under any heights. Under tunnels, the routes will be at a shorter distance, and under public places the overhead system will be at a much higher distance. So the contactors must always have a link between the overhead lines and the supply system of the locomotive. In fact, we have different types of contactors. We will see what are they. The first is a cable collector. This is used for small operational ranges where overhead equipment wire is hazardous. Basically, this is used in gaseous mines. The next is a pole collector. This is used in tramways. The next is a bow collector. This is used for higher speed. The disadvantage of bow collector is that it cannot be used at varying speeds. The next is a pantograph collector. Pantograph collectors are of two types, diamond type and single-ended Fabry type. The pantograph collector maintains link between the overhead system and power circuit of the locomotive at varying speeds in different climatic conditions on varying stiffnesses of the overhead equipment. Its operation is reversible and has got high current collection capacity. This is the diagram of a catenary. Catenary is an equipment which supports the overhead equipment. This not only supports the overhead equipment but also receives power from the substations and sends it to the overhead equipment, which is later on collected by the pantograph which connects the locomotive. The next is the circuit breakers used in overhead equipment. These are the two circuit breakers which are used in overhead equipment. They use compressed air. Next is the diagram of the different traction motors. This is a traction motor. This is the axle motor employed in the locomotives. Now we will just have a look at the traction substation. This is the diagram of a traction substation which consists of transformers, various types of transformers, and the circuit breakers. See, these are the different types of transformers. This is a transformer with 32 tappings. This is the main transformer. This is the transformer placed in the locomotive. Now we will look into the different traction systems. The first is the direct current system or DC system. The electrification in India started with direct current system. 0 to 750 volts is used for urban areas. 1500 to 3000 volts is used for suburban or mainline services. You will see here 0 to 750 volt supply is used in urban services. 1500 to 3000 volts is used for suburban and mainline services. In this system, the contact rail may be of the third rail type or an overhead conductor type. The third rail type is used for low voltages and the contact wire is used for higher voltages. The overhead conductors receive power from substations. The substations receive three-phase power which are converted into DC by using rotary converters. This is the diagram of a rotary converter which converts the three-phase system to the DC system. It also uses mercury arc rectifiers. The substations used in the DC system will have step-down transformers in connection with the frequency, the rectifiers, basically the mercury arc rectifiers. The very good properties of this system lie with the motor they are using, that is the DC series motor. The DC series motor has got very good properties required for track electrification. Now we will just have a look at the various advantages or the various characteristics of DC series motor. See, characteristics of DC series motor. When we draw a curve between the speed and the torque, we see that when the speed is less, the torque is more, and when the speed is more, the torque is less. The series motors have got very high starting torque for the given armature current. The torque is proportional to the square of the armature current up to saturation, and it is proportional to armature current afterwards. Also, the series motors have got good commutation properties. It has got smaller weight per HP ratio of the locomotive. It has got high acceleration and retardation rates. Because of high acceleration and retardation rates, this is generally used in urban areas where frequent stopping and starting is encountered. The next is its lower maintenance cost, and it has got high torque at low speeds and low torque at high speeds. In spite of all these advantages, DC series motor has got some disadvantages. They are: the cost of the substation laid for the DC system is high, because they have to use substations with step down transformers, and also they must use mercury arc rectifiers. Also, the number of substations required are more. In fact, for every 3 to 5 kilometers you have to install a substation for low voltages. For mainline services, the substations can be placed from 15 kilometers to 30 kilometers apart. Right? This causes deficiency in the flexibility of the system. Okay. Now, the next type of the system is single phase low frequency AC system. The single phase low frequency AC system has got many advantages. It improves the commutation properties, it increases the power factor and efficiency, it is suitable for operating voltages of 300 to 400 volts. Also, in order to provide economy of light overhead supply structures, the single conductor contact wire at high voltage of 15 kilovolt and frequency of 16 2/3 to 25 Hertz is used. The return, of course, is through the rail. The single phase low frequency AC system uses 15 kilovolt supply, and hence it requires a step down transformer which has to convert the 15 kilovolts to 300 to 400 kilovolts. Also, this system works under the frequency at a frequency of 16 2/3 Hertz or 25 Hertz, and hence special substations which are exclusively meant for the purpose are to be set up. which is a costly affair. So, in fact, the substations which supply industrial frequencies can also be used, but it is necessary to place a frequency converter equipment to convert the industrial frequency of say 50 Hertz in India to 16 2/3 or 25 Hertz. The voltage regulation of the series motors, AC series motor used in this system can be got from on-load tap changing gear equipment. This figure shows the on-load tap changing gear. Here we have a step down transformer which steps down the incoming 15 kilovolts to 300 to 400 volts in the secondary. We have different contactors C1, C2, C3, C4, C5 and C6. So, by closing any two contactors, the voltage can be set up in the motor. It is ensured that while changing the tappings, the voltage on the motor is not interrupted. If contactor C1 and C2 is closed, the voltage given to the motor will be the mean of the tapping voltages of these two closed contactors, and the circulating current is minimized by the choke coils. We see that the circulating current flows in the opposite directions through the choke coils, and hence the reactance losses are minimized. In order to increase the voltage given to the motor, contactor C1 is closed and contactor C3 is open. This results into the mean of voltages of C2 and C3 tappings given to the motor. In fact, this system has a major drawback that it is costly, because a special frequency converter equipment has to be placed for this system, right. The frequency converter equipment consists of 3-phase synchronous motor coupled with alternator set which takes power at 3 phase and supplies load at single phase. It avoids unbalanced loads thrown on the supply system. This is a frequency converter equipment. This has got the 3-phase synchronous motor coupled with the alternator set. This basically converts the industrial frequency to the required frequency of either 16 2/3 Hertz or 25 Hertz. The next type of the system is the 3-phase system. Before going into the 3-phase system, we will just have a look at the advantages of low frequency system. The low frequency system reduces voltage drop in the rails. It reduces telephonic interference. Its disadvantage is it is costly due to the advent of generating stations exclusively meant for the purpose, which supply high voltages with a frequency of 16 2/3 or 25 Hertz, or the provision of frequency converter equipment when supply is drawn from industrial frequency network. Now we shall look into the single phase high frequency systems. The single phase high frequency systems are basically used in gassy mines where the arcing between the overhead cables must be avoided. See, we will just have a look at the single phase high frequency AC system. Here we have got two overhead cables and we have got an energy receiver which receives power from the overhead cables through induction. The energy receiver is placed at a distance of 4 centimeters from the overhead cables. These overhead cables are supplied with high frequency generator. This high frequency generator supplies a frequency of 2500 to 3000 hertz. The energy receiver receives the alternating current through induction and hence it is rectified by using a rectifier and then sent to the traction motor. Here the traction motor used is a DC series motor and hence the voltage, the AC voltage received by the receiver has to be rectified by using a rectifier. The next system is 3-phase low frequency system. The 3-phase low frequency system has two conductors, two overhead conductors and the rail forming as a third phase. The advantages of this system is that it receives 3.3 kilovolts voltage at the industrial frequency of 50 hertz and hence no special transformers are required for this system. Also, we know that the induction motors are robust in construction and hence the robustness is high for this system. Now we will just have a look at the various advantages of this system. The two overhead conductors and rails form 3-phase supply for induction motor at 3.3 kilovolts and 16 2/3 hertz frequency. There is no need of transformer because induction motor can as well run with 3.3 kilovolts. It is robust and trouble free. It has automatic regenerative braking. This is a very important factor in 3-phase systems. In spite of all these advantages, there are some disadvantages. Hello? In spite of all these advantages, there are some disadvantages. Yeah? Two overhead conductors feeding the system becomes complicated at crossings and junctions. The constant speed characteristics of induction motor is not desirable. Induction motors have speed torque characteristics similar to DC motor which is not suitable for parallel operation. Hello sir? Hello?
Hello, he said that in olden days we used DC system.
Oh. Hello?
In olden days?
Yeah.
You told that we used DC system.
Even
system.
Yeah, nowadays also we are using DC system.
So my question is, the pantograph touches the overhead liner.
Yeah.
In this system the path development is high.
Yeah.
So how did they rectify that?
By using mercury arc rectifiers, we rectify the incoming AC voltage.
We will get DC, but in this system the spark will come very high now.
Right, that aspect we shall discuss in the next class.
Okay, thank you.
Now, so far we have seen about the various systems. These systems have got some disadvantage or the other. Now we look into the composite systems, which is a combination of any two of the above systems. This takes into consideration only the good qualities of the systems. The two composite systems which are majorly in use are the Kando system or single phase to three phase system and single phase to DC system. The single phase to three phase system is used in Italy in 1932, right. Here the overhead conductor, we just have a single overhead conductor which takes in the single phase supply and then converts into three phase supply by using a phase converter, phase converting equipment. The low starting torque of the induction motors can be improved by placing a three phase variable frequency inverter. We just have a look at the three phase variable frequency inverter. This is a three phase variable frequency inverter. This has got 6 SCRs in the circuit and we have got the diodes. The induction motor is connected to this frequency inverter. So when the frequency is limited, the impedance losses can be minimized, right, and also the high voltage, because of the high voltages in the three phase system, high acceleration rates can be produced and the starting torque can be increased. Now we shall look into a single phase to DC system. The single phase to DC system is used in India. Here the overhead conductors receive single phase voltage, it is rectified to DC and then sent to the DC series motors used in the locomotive. The advantages of 25 kilovolt AC system over DC system is that it has got light overhead catenary system. There will be a saving in substations. The substations can be placed farther apart, nearly 50 to 80 kilometers apart. The maximum coefficient of adhesion is possible and it has got high starting efficiency. So far we have discussed about the various aspects of track electrification. Now we will just have a recap of what all we have studied in today's class. We have looked into the classification, we have looked into the various equipment used in the system, we have also looked into the various systems of track electrification.